Welcome to Private Pilot Ground Lesson 10 on the free pilot training channel. In this lesson, we'll be discussing load factor. Anytime we're in straight and level flight, any lift that's produced will go straight up. We call this vertical lift. To stay straight and level, we only need to produce enough lift to equal the weight of the aircraft. If you remember from the last lesson, in order to turn the airplane, we need to roll one direction or the other. When we do this, some of the lift is pointed horizontally. It's that horizontal component of lift that causes the airplane to turn. But now in this condition, not only do we have to overcome weight, but we also have to overcome centrifugal force. Remember, Newton's first law of motion states that an object in motion will continue in motion until acted on by an outside force. When we change our direction of travel by adding horizontal lift, we are creating that force. Our airplane wants to continue going straight ahead, and that's the centrifugal force we have to overcome. So now we have to overcome weight and centrifugal force. When we combine these two, we get a resultant force known as the load. Now, because our load is greater than our weight, we need to produce more lift in the turn so we don't descend. We can do this by pulling back on the yoke, which increases our angle of attack. There are a couple ways we can increase the load on our airplane. If we increase the bank angle, it will also increase the load. This in turn will require more lift, which means more backstick pressure. Also, at higher airspeeds, centrifugal force is more difficult to overcome. Because of this, if you turn quickly, your load factor will also increase. Another way we can increase load factor is in a descent. When we pitch the nose of the airplane up, the airplane wanted to continue in the descent. This inertial tendency, along with weight, increases our load factor. But why do I care about all this? The wings of our airplane can only carry so much. By increasing the load factor, we increase the load that our wings have to carry. We measure load factor by g-forces, or g's. This is simply the force of gravity multiplied. For example, 1 g would equal the weight of our airplane. 2 g's would be the weight of our airplane times 2, and 3 g's would be the weight times 3, and so on. You'll find the G limitations for your aircraft in the POH or flight manual. If we exceed our airplane's G limits, we could potentially damage our airplane's wing structure, or worst case, we could break off the wings. Let's talk about a couple more things real quick before we get out of here today. One important thing for you to remember today is that anytime you increase your load factor, your stall speed will also increase. But remember, the airplane always stalls at the same angle of attack. Also, speed is the biggest contributor to higher load factor. The faster the airplane's moving, the easier it is to exceed your airplane's load limitations. Take a look at this diagram from the Pilot's Handbook of Aeronautical Knowledge. You'll see that on the left we have load factor and on the bottom we have speed. First, take a look at your normal stall speed. Up to this speed, your airplane will stall no matter what the load factor is. Now take a look at this curve. As load factor increases, our stall speed also increases, just like we talked about earlier. Now take a look at this. Every airplane has a maneuvering speed, also known as VA. Up to this speed, if you put too much of a load on the airplane, it will stall before any structural damage can happen. Now, if you exceed that maneuvering speed and the maximum load factor for your airplane, this is where you can start seeing structural damage or even structural failure. And that's just another reason why we want to keep an eye on our airspeed.